Going on now to topic 1 now of chapter 5, Exponents and Scientific Notation. Hopefully you've done some background. We had a quiz. I'm going to review the rules a little bit too. This is the product rule, where if the bases are the same and we are multiplying bases with exponents, we just add the exponents. So we'll give you a few moments and we'll pause from time to time and ask what you're getting, and then we'll go over them. So here our base is 2 and it's the same, and 3 plus 4 will be 7. Now here you have to recall there is a 1 by this m. When there's no written exponent, there's a 1 there. So as we add up our exponents, 1 plus 9, 10 plus 7 is 17. Now here we have to multiply the coefficients, the numerical coefficients. Negative 6 times 6 is a negative 36. X is to the first, and if it's to the first, we don't write anything. And then there's a 1 and a 1 on the y's, so that's to the second. And here we have a negative 3 times a negative 5 gives us a positive 15. And then A, 3 plus 3 is 6. B, 2 plus 1 is 3. So that's pretty straightforward. Now the rule for row 2 is anything to the 0 power is a 1. And the proof of that, and we'll see it later, but I'll show you now, is if you have a to the third divided by a to the third, we had said the rule is you take the exponent of the base of the denominator as it crosses this division bar, the sign of the exponent changes, and we get a to the third minus 3 is going to be a to the 0 power. Now we also have the rule that anything a to the third divided by itself, a to the third, as long as a is not a 0, is going to be a 1. So there's the proof of it, and the key is, what is the base? What is the exponent? Well, here our base is 2, and it's to the 0 power, so this will be a 1. Now, what's our base here? Negative 5 or just the 5? Just the 5. So it's 5 to the 0 power, then we apply the 1. I'm sorry, the negative to the 1. Another way to look at this is negative and put the 5 to the 0 power in parentheses. This is a 1, and then that's negative is applied. Now here the base is negative 10, and what's in the parentheses now to the 0 power is going to be 1. Again, all of this is the base that's to the 0 power. So this is going to equal 1. Now as we do row 3, we'll introduce the rule here. A to the m divided by a to the n. Well, we said we take the exponent of the base of our denominator. As it crosses this division line, the sign of the exponent changes and it becomes negative. By the way, if we were multiplying and we added, dividing would be analogous to subtraction. So we have x, and then bring the 3 up. 8 minus 3 is x to the 5th. Now keep in mind the negative sign is there, so this answer will be negative. 2 goes into 10 5 times, and then 7 from 11 will be y to the 4th. Now here it doesn't go evenly, or it makes a whole number, but there's going to be a fraction. So we could take a 3 out of the 15, and that would be a 5 left there. And a 3 out of the 9, and that would be a 3. And then x to the 1st subtracted from the 6th would be x to the 5th. Y, we're going to subtract the 3 from the 5 and get 2. Now you can put this all over like this, or you could actually do a little separation there and write it this way, and without that division bar there. Now a negative 4 goes evenly into a 36. That would be a negative 9. And then a to the 1st subtracted from a to the 2nd is a to the 1st. We don't write the 1. b to the 1st subtracted from b to the 3rd will be b to the 2nd. And 9 subtracted from 12 is c to the 3rd. So again, still pretty easy, and hopefully you're following along. And if you ever have a question, of course, ask your questions. So the rule here is if we have something like this, a with a negative exponent, remember this is over 1, and there's a 1 up there as well that we don't write. The 1 will remain in the numerator. We bring our base and negative exponent down. As it crosses that division bar, the sign of the exponent changes. So here this is going to be 1 over 2 to the 4th. The sign of the exponent changes, and then we're asked to simplify. And 2 to the 4th is 16. Again, this is going to be 1 over negative 3 to the positive 2 now, which, when we simplify that, squaring a negative 3, because that's the base, this becomes a 9. Again, we're going to keep the 1 in the numerator, bring this down. We have y to the 6th already there. This will become a positive 3. 6 plus 3 is 9. Now this is interesting because students have made an error here. What's our base? Well, our base is only the a. So the 2 remains in the numerator, and as we bring the a down, the sign of the exponent changes. Now, the rule generally is to keep your exponents positive. So we can do a little simplification here. If I add a negative 5 and a 4, I get x to the negative 1 up there. And if I take my exponent from the denominator now and move it up, it's going to become a positive 2. Positive 2 and a negative 1 just leaves me with an x in the numerator. So once again, when we did the plus, or the plus 4 and the negative 5, that gave us a negative 1. We brought the negative 2 up, that became a positive 2, which left us with x to the first. We don't write the 1. Now the 4 will go into 12 evenly, and that would be 3. And we're going to bring our negative a, or a to the negative 3 up. There's a 1 there. So this will make this a to the 4th. Bringing this negative 3 up becomes a positive. 1 plus 3 is 4. And we'll want to bring this negative 3 in the numerator down. It'll become a positive 3, so that will be b to the 6th. And of course you'll have practice with this. Now 2 will go into 20 10 times. And we're going to bring the negative 8 down. So down here becomes a positive 8, and the 1 that's there already, this will be x to the 9th. Now interestingly, the y's will cancel out, and we're bringing the negative 13 of the z down. There's a 1 there, and 13 becomes z to the 14th power. And MATLAB will center that up nicely here. Okay, so here we have 3 times a negative 2, which gives us a negative 6. A to the 3rd, a to the negative 4. So this is going to be a to the negative 1 when we add these together. So we'll move that down to the denominator as a positive a. And then b to the 1st here. And a negative 2 leaves in the numerator b to the negative 1 that I'll bring down here as a positive 1. And there's our answer. Now a quick review on scientific notation is we want to end up with a number between 1 and 10, and then depending how many decimal places we had to move it, if it's a large number it'll be positive powers of 10. If it's a small number it will be negative powers of 10. So we're going to move this, we'll count it together. 1, 2, 3, 4, 5. So our exponent here is going to be a 5. And our number will be 6.45. We want to make it a number between 1 and 10. We move the decimal place over. If you can remember, moving the decimal place to the left, that is, it's a big number, it's positive exponents of 10. Small numbers, let's make this a number between 1 and 10. 1, 2, 3. So this will be 5.621. And I've moved it 1, 2, 3, so negative 3. Now here our number is 3.6. It's negative powers of 10, so we have to move this decimal 4 places to make it a small number, so it'll be to the left. So we have 1 decimal place already, so we need to add 3 zeros, so that when I move it over, 1, 2, 3, 4, and we usually add an extra 0 to fix it. We now have it in standard notation. And here, again, we have 9.5. We're going to move it 5 decimal places. And I'm going to have to move this a little bit here. So 9.5, it's a positive exponent. So I'm going to add places now to the right. So there's one place. I need 5. So 4 zeros. 1, 2, 3, 4. So when I move it 5 places now, I get my number in standard notation. Okay.